Dear students, in this video, I am going to explain about lesson number 2, quantum mechanical model of atom, topic number 10, magnetic quantum number and spin quantum number. What are called as quantum number? The location of electron in an atom can be identified by the set of values called quantum numbers. Quantum numbers are divided into 4 types: principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. In our last video, we discussed about principal quantum number and azimuthal quantum number, and now in this class we are going to see about magnetic quantum number and spin quantum number. What is called as magnetic quantum number? It is denoted by the symbol m. It can also be denoted by the symbol m to the base L. Both the symbols are correct. What does the magnetic quantum number value tells us? It represents the orientation of atomic orbital in space. In the last video, we discussed that there are 4 different atomic orbital: s orbital, p orbital, d orbital, f orbital. S orbital has spherical shape, p orbital has dumbbell shape, d orbital has double or clover leaf shape, and f orbital has diffused shape. In such a way we discussed how far the electrons are distributed in different orbital. In what are the directions does the electrons are distributed in different orbital, that is called as orientation of atomic orbital in space. So we can able to calculate the magnetic quantum number value from the azimuthal quantum number value L. So if we know the azimuthal quantum number value, we can able to calculate the magnetic quantum number value. How to calculate the magnetic quantum number value? The formula to calculate magnetic quantum number is m is equal to minus L to plus L through 0. Minus L to plus L through 0. It means if L is equal to 0, means m value also will become equal to 0. If L is equal to 1 means m value will be equal to minus 1, 0, plus 1. So 3 different values are possible when L is equal to 1. 3 magnetic quantum numbers values are obtained when L is equal to 1. Suppose if L is equal to 2, what we will be getting? M is equal to minus 2, minus 1, 0, plus 1, plus 2. Nearly 5 different values are possible for m value whenever L is equal to 2. In such a way, we have to calculate different m value by substituting different L value. So based on the L value and m value, we can able to identify the orientation of atomic orbital in space. The distribution of electrons in various orbitals in space can be calculated from the L value and from the m value. Let us see it clearly with the help of this table. This table as usual divided into 4 types. First one, n. N represents the principal quantum number. From the n value, we can able to calculate L value as we discussed in the previous class. Now here, from the L value, we are going to calculate m value. As I told you now, m is equal to minus L to plus L through 0. After calculating m value, we can able to come to the conclusion regarding the subshell or orientation with their orientation. Orbital orientation or subshell orientation we can able to calculate. Now let us see one by one. When n is equal to 1, L will have only one value, 0. When n is equal to 2, L will have 2 value, that is 0 and 1. When n is equal to 3, L will have 3 value, 0, 1 and 2. When n is equal to 4, L will have 4 value, that is 0, 1, 2 and 3. Now from n we have calculated L. Now from L, how to calculate m? When L is equal to 0, what does L is equal to 0 represent? It represents the s orbital. L is equal to 0 means s orbital. If L is equal to 0, then m value will be 0. M value will be 0 means m is having only one value, that is 0, which means s orbital is spherical in nature. Electrons are distributed uniformly in a spherical direction. What about L is equal to 1? L is equal to 1 means it represents p orbital. For L is equal to 1, we get 3 values for m, which means p orbital in electrons. The electrons in p orbitals are distributed in 3 different directions. They are nothing but px, py, pz. For second orbit, it is 2px, 2py, 2pz. For third orbit, it is 3px, 3py, 3pz. And for fourth orbit, it is 4px, 4py, 4pz. Whatever the orbit might be, p orbital has 3 different values. The electrons are distributed in 3 different directions. What about L is equal to 2? L is equal to 2 means it represents the d orbital. For L is equal to 2, we get 5 different values for m. Minus 2, minus 1, 0, plus 1 and plus 2. 5 different values are possible. Which means the electrons present in d orbital are distributed in 5 different directions. What are they? 3 dxy, dyz, dxz, dx square minus y square, dz square. For if it is a third orbit, it is represented as 3dxy, 3dyz, 3dxz, 3dx square minus y square, 3dz square. If it is a fourth orbit, it is represented as 4dxy, 4dyz, 4dxz, 4dx square minus y square, 4dz square. What about L is equal to 3? Whenever L is equal to 3, it represents the f orbital. For f orbital, m values are minus 3 to plus 3 through 0. That is, we have 7 different values, which means the electron present in f orbital are distributed in 7 different directions. What are they? Fy into 3x square minus y square, fz into x square minus y square, fyz square, fz cube, fxz square, fxyz, fx into x square minus 3y square. If the f subshell are present in fourth orbit, it is represented along with 4. If it is present in fifth orbit, it is represented along with 5. So these are the orientations. These are the different orientations of orbital having different values. These values are calculated from m value, and the m values are mainly depends upon the L value. So these are something about the magnetic quantum number. The next quantum number is spin quantum number. It is denoted by the symbol m to the base s. It represents the spin of electron. Each and every orbital, whether it is a s orbital or p orbital or d orbital or f orbital, there are chances to hold either one electron in each orbital or 2 electron in each orbital. If only one electron is there, it is represented like this. If 2 electrons are there in one orbital, it will be represented like this. There are 2 chances, either holding 1 electron in each orbital or holding 2 electron in each orbital. So if 2 electrons are there in every orbital, the spin of electron, the electron will revolve around the nucleus by spinning in its own axis. If 2 electrons are there in one orbital, the spin of each electron will be in opposite direction. That is, one electron will spin in clockwise direction and another electron will spin in anti-clockwise direction. If 2 electrons are there in one orbital, one will spin in its own axis in clockwise direction and another electron will spin in its own axis in anti-clockwise direction. Suppose if we have only one electron in the orbital, let us imagine a orbital that has only one electron. If only one electron is there, means it will rotate or it will spin in clockwise direction alone. So overall, there are chances for the electron to spin in 2 directions, either in clockwise direction or in anti-clockwise direction. But this visualization, this concept of spin of electrons around the nucleus, this visualization is not true. However, spin of electron is a property that is revealed itself in a magnetic field. In presence of magnetic field, we can able to obtain the spin of electron in its own axis along with the movement of electron in an orbit. Corresponding to clockwise or anti-clockwise spin of electron, maximum of 2 values are possible for this quantum number. They are nothing but minus 1 by 2 and plus 1 by 2. M can have only 2 value, minus 1 by 2 and plus 1 by 2. Plus 1 by 2 can be given for the electron having spin in the clockwise direction. Minus 1 by 2 can be given for the electron having spin in the anti-clockwise direction. Can you able to understand? If an electron spin in the clockwise direction, it is given with plus 1 by 2. its value is given with the plus 1 by 2. Look at this diagram. Here the electron is revolving in the upward direction. The upward arrow mark is given now. So it means that the electrons are revolving in the clockwise direction. So for this electron I have given the value as plus 1 by 2. Come to the next one. Next is picture. Here the electron are denoted in the downward arrow mark. So here, which means the electrons are revolving in the anti-clockwise direction. So the value for spin quantum number for this electron is minus 1 by 2. So in case of spin quantum number, an electron can have either one of the two values, that is minus 1 by 2 or plus 1 by 2, based upon the spin of axis. If the spin is in clockwise direction, it will have plus 1 by 2, and if the spin of electron is in the anti-clockwise direction, it will have minus 1 by 2. So these are the important phenomenon regarding the spin quantum number. So students, in the last video and this video, we discussed 4 important quantum number. These quantum numbers are used to give us information regarding the location of electrons in an atom in different various orbit and different various orbital and subcells. Thank you.